We are going to start now the second chapter, linear inequalities, and this is lecture 1. So in this chapter we will discuss some simultaneous inequations in one variables and certain word problems based upon those methods. So first of all we will see that what is the method to solve the simultaneous equations. So simultaneous equation means, suppose I am talking about the equation of the form 2x plus 3 is greater than 4 and say 7x minus 2 is less than 3, and I am talking about all those values of x such that x satisfies both these equations simultaneously. So what we have to do, we have to solve this inequation, we have to solve this part, and we are interested in those values of x which satisfy this and this. It means we are talking about whatever the answers we obtain for this, we will take the intersection of those answers, because we are interested in the common values of x which satisfies this as well as this inequation. So let us start with an example. Solve the inequation this and represent the solution on the real number line. So we are given minus 3 is less than equal to 3 minus 2x is less than 9. Why these are simultaneous equations? We are saying this part, consider this part only. What we get, it is minus 3 is less than equal to 3 minus 2x. Now consider this part. We have 3 minus 2x is less than 9. These are the two equations we have. If we solve this portion, we know how to solve this. We will shift this term on this side, we will send this term on this side. We are using the transposition. So we will get 2x is less than equal to 3 plus 3, and this implies us 2x is less than equal to 6, and this implies us that x is less than equal to 3. So the solution in this case, x is less than equal to 3, how we are representing it? We are talking about all real numbers less than 3. In interval form, we can write it in this way, minus infinity to 3. It is closed over here because less than equal to sign is there. So interval it is closed at 3. Now we consider this part. We write it in the form that 3 minus 9 is less than 2x. This thing implies this, and this thing implies us that 2x is greater than minus 6. So this implies us that x is greater than minus 3. X is greater than minus 3. How we represent it in interval form? We are talking about all real numbers which are greater than minus 3. This is greater than is there, so open bracket is there up to infinity. At infinity and minus infinity we always have the open brackets, so we write the answer in this form. This is the solution for this inequality. This is the solution of this inequality. When we are saying we are interested in those values of x which satisfies both these conditions, it means we are talking about the intersection of these two. We are talking about the points minus 3, 0, 3. What this is representing? Minus infinity to 3, and it is closed over here. Minus 3 to infinity with open over here. We are interested in intersection, it means we are talking about this common portion. This common portion we are talking about. So what is common over here? Is minus 3 included in this interval? No. Minus 3 is not included in this interval. 3 is included in this interval. The common portion we obtain, this is this region of the line, this is common. 3 is included, minus 3 is not included. So the answer we obtain for this, the possible values of x that we have is that x belongs to the interval minus 3 to 3. So this is the solution set we have. This is the solution set, or another way of writing this set, this is interval form. We can also write it x such that x is a real number, minus 3 is less than x is less than equal to 3. This is another way to write this set. So this is the better way or compact form, that is the interval form. Let's consider another example. Solve the inequation. The first part we have it is 2x minus 3 is less than x plus 2. This is one inequation. Second we have is x plus 2 is less than equal to 3x plus 5. These are the two inequations that we have. When you will solve this part, this x we will send over here, we will get x is less than 5. X is less than 5 means we are talking about what interval it is represented. It means x belongs to minus infinity to 5. Open interval we have. When we are talking about this second part, and you will solve this, you will get minus 2x is less than equal to 3. So what we get is x is greater than equal to minus 3 by 2. Why minus over here? We are saying when we will divide with a term with negative sign, the sign of this inequality will change. We have minus 2 over here. When we are dividing both sides with minus 2, the sign of this inequality change. This thing we have already seen when we were talking about the operations, how we will solve the linear inequalities. Now what this is, x is greater than minus 3 by 2. It is greater than equal to, closed bracket is there, minus 3 by 2. The starting point is minus 3 by 2 and it will go up to infinity, open bracket is there. So in this case x belongs to this set. In this case x belongs to this. Now if both the inequalities are satisfied simultaneously, we are talking about one point is minus 3 by 2, another point we have it is 5, but this is minus infinity to 5, but this is minus 3 by 2 to infinity. What is common over here? This portion is common. This point minus 3 by 2, it is included. This point 5, it is not included. So we are saying x belongs to minus 3 by 2 to 5. So this is the final answer we have for this case. Next question we have is in this form. So you can try this question at your own. You can try this question. This is a similar question we have. What you have to do, you have to divide this inequality, 2 minus 3x by 4. Second part, 2x minus 3x by 4 is less than equal to 9. Shift this 4 on this side, you will get minus 20 is less than equal to 2 minus 3x. Over here you will get 2x minus 2 minus, this is not 2x, this is 2 minus 3x is less than equal to 28. So these are the two inequalities we have obtained, and when you will solve this, you will obtain two different intervals, and corresponding to those intervals, you can note that when you will solve this part, you will obtain the interval in the form minus infinity to 22 by 3. Closed. You can try at your own solving this, and in the second case you will get it is minus 34 by 3 to infinity. You will get the answer in this. Then you will plot all these points on the number line. You will see what is the common region over there, and the final answer that you will obtain, that will be minus 34 by 3 to 22 by 3. So you can try this question yourself and try to obtain this answer. Next we have is the analysis of products and quotients. So when we are talking about that, we have two numbers A and B, and we are saying A into B is greater than 0 or A over B is greater than 0. We are talking about the first case where we are saying we have the positive result. We are taking the product, or we are taking the quotients. When we are talking about quotients, it means we are assuming that A and B, they are not equal to 0. Otherwise, these calculations, they will become 0, and B cannot be 0 because when we are talking about A by B, the division is not defined. So we are talking about the non-zero numbers over here. We are saying A into B or A upon B is positive. Then what are the possible cases? We are talking about that A into B is greater than 0. We have two cases. If A is greater than 0, then clearly B is also greater than 0. Only then the product can be greater than 0. Similarly, we are talking about A by B. If A is less than 0, then we will have B is less than 0. We are saying that if the product is positive, then either both the numbers are positive or both the numbers, they are negative. Similarly, if the product is negative, if we are saying we have two numbers A and B, we are talking about A into B or A by B, and we are talking about the case if this value is less than 0, then what are the possible cases? There are two possible cases. We are saying if A is negative, then B should be positive. The signs are opposite. The signs of A and B, they are opposite. Only then A into B or A by B, they will be A into B or A by B will be negative. Or we are saying if A is negative, then B will be positive. We will have the results in this form. Next is the zero product. If we have the product of two numbers A and B, if we are saying if A or B it is 0, then A into B will be 0. Again, or is there, it means we are already considering in this that both are 0, then A into B is 0. Or in another sense, we are saying if A into B is 0, when is this possible? We are saying either A is equal to 0 or B is equal to 0 or both are 0. We are not talking about the division in this case, because when we are talking about the division, then B can never be equal to 0. In that case, the only thing we have is that A is equal to 0. Next, we are considering this case 0 in division. So we are saying if A is equal to 0 and B is not equal to 0, then A by B is 0, numerator is 0. This case is important. If the denominator is 0, we will say A by B is undefined. This number A by B, it is undefined when B is equal to 0. The division is not defined when for the denominator to be 0. So this remark is given over here that division by 0 is not allowed. That is, A by 0 has no valid mathematical result and it has no valid mathematical meaning. So let's try to solve certain problems now. Now we have to solve and graph the solution set for the inequality. X minus 3 over x plus 4 is less than 0. So how we are going to consider these kind of inequalities? These are rational polynomials. These are rational polynomials. So whenever a rational polynomial is given to us, the first thing that we have to do is the denominator should not be equal to 0. Whenever the rational polynomial is given, first of all identify the points x for which denominator is 0. To find those points, we are equating x plus 4 is equal to 0, and we obtain that x cannot be equal to minus 4. We have to solve this inequation. The first step, whenever there is a division and there is a polynomial lying over here, first of all identify the 0 points. In this case, we are saying that first condition we have obtained is that x cannot be equal to minus 4, because if x is minus 4, we have no answer over there. Next, we are going to solve this. Now, to solve this condition, this is of the form a by b, we are saying this term is less than 0. So there are two cases. First case is that x minus 3, it is 0, is less than 0, or we will have x minus 3 is greater than 0. The numerator we have either it is less than 0 or numerator it is greater than 0. If x minus 3 is less than 0 and the division of these two is less than 0, it means this value x plus 4 is greater than 0. This is the case we are talking about. We are saying the division of two numbers, it is less than 0. It means that these two numbers, they have the opposite sign. So if we are saying that the numerator is negative, it means denominator is positive. If numerator is positive, it means denominator is negative. So this question, the first condition we have obtained over here, that x cannot be equal to minus 4, this is because denominator cannot be 0. We obtain, this is simultaneous inequation that we have derived from this. This is simultaneous inequation that we have derived from this. Let us try to solve these two. We are saying, and we have or. In between these two, we are saying either this will hold or this will hold. In this case, we are saying if it is like this, it is and. It is not or. We are not saying either this will hold or this will hold. We are saying if this will hold, then this will also hold. If this will hold, it is and over here, this will also. Now, look at these terms. We are using and over here and we are using or over here. Because if this condition holds, that will not hold. If this condition holds, this will not hold. So we are using or over here. These two conditions, they will hold simultaneously. We are using and over here. Now, this thing gives us x is less than 3 and x is greater than minus 4. It is and over here. It means both these conditions should be satisfied together. We have this is the point 3, this is the point minus 4. X is less than 3. X is greater than minus 4. And is there in between. We are talking about the common region. The answer we obtain, it is minus 4 and 3 with the open bracket. We will have minus 4 comma 3 with the open brackets. Look at this case. X is greater than 3 and x is less than minus 4. We are interested in those values of x for which x is greater than 3 and x is less than minus 4. So is there any x which satisfies both these conditions? We want a value of x for which x is greater than 3 and x is less than -4. There is no common value over here which satisfies both these conditions. So we are saying that this set it is 5. This set we have it is 5. Now what we have obtained over here, x cannot be equal to -4. X can be in the interval -4 to 3, or we are talking about the empty set. I'm listing all these three conditions over here. What we have obtained, we are saying first condition is x cannot be equal to -4 because of this denominator. Second, we are saying x belongs to -4, 3, or from the third we are obtaining the set 5. Now between these two conditions we were having or, it means we were talking about, whenever we are having or, we are talking about the union of these two sets. It is -4, 3 union a union 5. We know that is equal to a. X cannot be -4. -4 is already excluded over here. Open bracket is there. It means that the solution set that we have in this case, it is -4, 3. This is the solution set in this case. Let's consider another example. This inequality is given now. It is 5 over x minus 2 is greater than 3. So if we will add 3, or we are saying we subtract 3 on both sides, this inequation will become 5 over x minus 2 minus 3 is greater than 0. We are subtracting 3 on both sides, or we are saying that we have done the transposition. And when we will solve this, we will get it is 5 minus 3 into x minus 2 over x minus 2 is greater than 0. This implies us 5 minus 3x plus 6 over x minus 2 is greater than 0. And this implies us that 11 minus 3x over x minus 2 is greater than 0. So we are saying that solving this inequation, it is equivalent to solving the equation 11 minus 3x over x minus 2 is greater than 0. We are saying the solution set for this and solution set for this, both the sets, they are equal. Now to solve this, what we have to do, the denominator, first is identifying the 0 point. Denominator should not be 0. How we obtain this? Equate x minus 2 to 0, you will get x is not equal to 2. Second, we will have two cases. This value is greater than 0. This value is greater than 0 means either both are positive or both numerator and denominator are negative. 11 minus 3x is greater than 0 and x minus 2 is greater than 0, or both are negative. Either both are positive or both are negative. So when you will solve these, try it at your own. Try to solve both these inequations, plot them on number line, look at the answer that you will obtain. In this case, the answer you will obtain, it is 2 is less than x is less than 11 by 3. This will be the answer you will obtain in this case. When we are talking about this OR condition, we will see that there is no solution in this case. There will be no solution in this case. You can try at your own. After this, it is OR over here. We are talking about the union of these two. You will obtain an answer as the union of these two. That answer will be 2 over 11 by 3. When you will take the union, this will be the answer. X is not equal to 2. This condition is already adjusted over here. So this will be the answer in this case. So you can try to solve this inequation and see what is the answer. Let's solve another similar problem. We are saying x plus 4 over x minus 2 is greater than 0. First condition, equate this to 0, you will obtain x is not equal to 2. You will obtain x is not equal to 2. Second, this value is greater than 0. So, x plus 4 is greater than 0. X minus 2 is greater than 0. X plus 4 is less than 0. X minus 2 is less than 0. That is, either both numerator and denominator will be positive or both numerator and denominator will be negative. X is greater than minus 4. X is greater than 2. Minus 4, 2. X is greater than minus 4. X is greater than 2. The common value we have is x is greater than 2. The answer we obtain is interval 2 to infinity. Second case, x is less than minus 4 and x is less than 2. Plot these. Minus 4, 2. X is less than minus 4. Minus 4 is excluded. X is less than 2. 2 is excluded. Common value we have is x belongs to minus infinity comma minus 4. That is, x is less than minus 4. It is or in between these two values. So what is the union of these two? We are saying we have the point minus 4, we have the point 2. We have the region 2 is x is greater than 2. We have the region x is less than minus 4. The union of both these are minus infinity comma minus 4 union 2 comma infinity. This is the union of these two intervals. X is not equal to 2. This case, it is already adjusted over here. X is not equal to 2. All conditions are satisfied. This is the solution set in this case. Next is x minus 2 over x plus 5 is greater than 2. So again we transform this inequality. We write it x minus 2 over x plus 5 is greater than 2. This implies us x minus 2 over x plus 5 minus 2 is greater than 0. Take the LCM, solve this value. You will obtain x plus 12 over x plus 5. You try to solve this, try to obtain this answer, and this value is less than 0. So this inequality will come in this form. Now denominator should not be 0. It means x cannot be equal to minus 5. This value is less than 0. The sign of both these terms should be opposite. If you are considering numerator as positive, consider denominator is negative. When denominator is positive, consider numerator is positive. Make two different cases. Try to solve them. Take the union. Adjust this value that x is not equal to minus 5 and you will obtain the final answer. And the final answer in this case that we have, it is minus 12 to minus 5 with the open interval. You will obtain the final answer as this. So you try to solve this inequation at your own. Next, solve the system of inequations. So these inequations are given and we have to solve them. Now, first of all, we try to simplify both these values. When we are talking about this first case, we can cross multiply the terms or we shift this term on this side. Why we are not cross multiplying it? Consider, this is an important point to consider over here. If suppose you start doing it like this, 6x, you multiply it over here, is less than 4x minus 1. If you start solving it like this, then what is the problem? If you have shifted this term over here, 4x minus 1, it means you have multiplied both sides of this equation with 4x minus 1. You have not changed the sign, it means you are assuming this thing that 4x minus 1 is greater than 0. If we are cross multiplying these terms, if we shift 2 over here, we can shift it because we know 2 is positive, it will not change the sign of inequality. But we do not know whether 4x minus 1 is positive or negative. If we will shift it over here and we don't change the sign, it means we are considering that it is positive. So we cannot shift this 4x minus 1 on that side. In place of this, what we are going to do? We are going to write 6x over 4x minus 1 by 2 is less than 0. X over 2x plus 1 minus 1 by 4 is greater than equal to 0. These are the two equations that we obtain. Now take the LCM and solve these equations. It will become 12x minus 4x plus 1, minus sign is there. Be very cautious when you are writing this value, it is plus 1 over here, divided by 2 into 4x minus 1, and this value is less than 0. When you will solve this, you will get 8x plus 1 divided by 2 into 4x minus 1 is less than 0. We can adjust this, multiply this 2 over here, and we are left with this inequality. Similarly, for the second part, when we are talking about x over 2x plus 1, we have shifted, we have written 1 by 4 on this side, and when you will solve this, and you will solve this value, the final answer you will obtain, it is 2x minus 1 over 2x plus 1 is greater than equal to 0. Now, what our question is transformed to, earlier these were the two inequalities given to us. This inequality changes to, this inequality, it has changed to 8x plus 1 over 4x minus 1 is less than 0. This inequality, it has changed to 2x minus 1 over 2x plus 1 is greater than equal to 0. These are simultaneous inequalities. We are talking about those values of x which satisfies both these conditions. When we solve this, we are writing x should not be equal to, if we equate the denominator equal to 0, we will get x should not be equal to 1 by 4. When we are solving that part, we are saying x should not be equal to minus 1 by 2. X should not be equal to minus 1 by 2. X should not be equal to 1 by 4. There are two cases over here. 8x plus 1 over 4x minus 1 is less than 0. Negative. When we are talking about this term is negative, two cases arise. 8x plus 1, if it is greater than 0, 4x minus 1 will be less than 0. Opposite signs. 8x plus 1 is less than 0, 4x minus 1 will be greater than 0. Opposite sign. This gives us x is greater than minus 1 by 8. This gives us x is less than 1 by 4. Number line is there, x is greater than minus 1 by 8, x is less than 1 by 4. We are talking about this region. In this case, we are saying x is less than minus 1 by 8, x is greater than 1 by 4. Plot these points, minus 1 by 8, 1 by 4, x is less than minus 1 by 8, x is greater than 1 by 4, no common value, phi, either of these two cases holds, it is OR over here. OR means we are talking about the union of these two. The answer we have is minus 1 by 8 comma 1 by 4. In the second case, again we will have two inequalities over there. It is positive, it means if 2x minus 1 is greater than equal to 0, 2x plus 1 is greater than equal to 0. It is greater than sign over here because it cannot be equal to 0. And in the second case we are saying, or if you are writing it like this, we have already considered that x is not equal to minus 1 by 2. We are saying if 2x minus 1 is less than equal to 0, then 2x plus 1 is less than equal to 0. So when we are talking about, it is better to remove these equal to signs over here because otherwise it will create more confusion. Now, because equal to sign, denominator, it is not possible to equate it equal to 0, so that is why we have removed this equality sign. Now when both the terms they are positive, what we get is x is greater than equal to 1 by 2, x is greater than minus 1 by 2, minus 1 by 2, 1 by 2, x is greater than minus 1 by 2, x is greater than equal to 1 by 2. The answer we obtain it is 1 by 2 comma infinity. In this case, what we will obtain, x is less than equal to 1 by 2, x is less than minus 1 by 2. We are saying x is less than equal to 1 by 2, and second we are saying x is less than minus 1 by 2. So the answer in this case that we will obtain, we have points like this. This is minus 1 by 2, this is 1 by 2. So we are saying x is less than equal to 1 by 2. X is less than equal to 1 by 2. X is less than, this is open bracket, open over here, 1 by 2. And the common values we obtain it is x belongs to minus infinity to, x belongs to minus infinity to minus 1 by 2. Both brackets they are open. So in this case, the solution set is the union of these two. The union of these two is minus infinity comma minus 1 by 2 open, union, closed interval 1 by 2 to infinity. Closed interval 1 by 2 to infinity. This is the solution set, minus 1 by 8, 1 by 4, and this is the solution set we have in this case. X is not equal to 1 by 4, included over here. X is not equal to minus 1 by 2, included over here. Now, this thing we have solved. Now, what is the final answer? We are saying the solution set for this inequality we have, it is minus 1 by 8 comma 1 by 4. The solution set for this inequality we have, it is minus infinity comma minus 1 by 2 union 1 by 2 comma infinity. This is the answer we have obtained till now. Now both are simultaneous equations. It means we are interested in those values of x which satisfies both these conditions. Plot these points on the number line. Minus 1 by 2, minus 1 by 8, 1 by 4. These are the points we are interested in. And another point we have, it is 1 by 2. Minus 1 by 8 to 1 by 4. Open bracket. This is one region. Minus infinity to minus 1 by 2. Open bracket. This is corresponding to this. This is corresponding to this. And 1 by 2 to infinity. We have this. So there is no common region. So what we obtain is that there is no solution for this inequality. There is no solution for this inequality. Next, suppose these are the two polynomials given to us. We are talking about the polynomial functions. So right now we are not calling them the polynomial function. We are just saying we have two polynomials. One is fx, we are writing it is 2x minus 1, and another is gx, we are writing it is equal to gx is equal to 5. I am talking about these three cases. First is fx is equal to gx. Fx is equal to gx means I am trying to solve 2x minus 1 is equal to 5. Fx is less than gx. 2x minus 1 is less than 5. And 2x minus 1 is greater than 5. We are trying to solve these three inequalities. So first of all, we are going to plot y is equal to fx and y is equal to gx. Y is equal to fx means we are saying y is equal to 2x minus 1 and y is equal to 5. These are the lines. When we are talking about y is equal to 2x, then to plot this line, we will substitute different values. I am talking about this line. If I will substitute x is equal to 0, I will obtain y is equal to minus 1. This is one point we are getting. Now if I am substituting x is equal to 1, I am substituting x is equal to 1, I will get the value of y is equal to 1. These are the 2 points we have obtained. One is the point 0 and minus 1. Somewhere over here, this is the point 0 comma minus 1. Another point we have obtained, it is 1 comma 1. Another point, so this is the point 1 comma 1. So this is the line we are talking about. This is the line y is equal to 2x minus 1. Now somewhere over here we will have y is equal to 5. So this is the line we are talking over here. This is y is equal to 5. And if we are saying this is the point of intersection, how we are going to calculate it? We are talking about y is equal to 2x minus 1, y is equal to 5. If we substitute this value over here, we will get 5 is equal to 2x minus 1. This implies us x is equal to, we will shift over here, this is 6 divided by 2, that is 3. It means this point we are having over here, it is 3 comma 5. This point we have over here, it is 3 comma 5. Now we are going to talk about these three cases graphically. When we are saying 2x minus 1 is equal to 5, when we are talking about this value, it means we are talking about this particular point 3 comma 5. We are talking about this particular point, the value of x that we obtain, that is 3 over here. We are talking about this point 3 comma 5. So we have two equations, y is equal to 2x minus 1, one is y is equal to 5. When we are talking about fx is equal to gx, these two values, these are equal only at the point 3 comma 5. At the point 3 comma 5, fx will be equal to gx. Now we are saying fx is less than gx. We are having two curves. This curve we are saying this is fx, and this line we are saying this is gx. You can say curve or you can say line. What is the region or what is the area under which we are saying fx is less than gx. These are the values of fx. These are the values of gx. So in this portion we are saying, in this portion, this complete portion we are talking about, or up to this point we are saying, up to this point, this portion we are talking about, in this region, we have fx is less than gx. And if we extend it like this, in this portion we are saying we have fx is greater than gx. This is the line y is equal to 5. In this portion we have fx is greater than gx. In this portion we have fx is less than gx. We are saying this is the line gx, and fx is less than gx for this portion, and after, at this point both are equal, and after this we have fx is greater than gx. This is the graphical representation of the inequalities that we have. So these things in our next class we will see in details that what is happening over here. I am just giving an idea, an overview that what fx is less than gx and fx is greater than gx means over here. In next class things will be more clear to you. The next thing we have is the word problems. So you can these are provided in your notes, so you can just give a quick revision or quick look at what we are trying to say over there. The things will be more clear to you when we will move to our next class. Class means next topic. Now first problem we have is find all pair of consecutive all positive integers. We want consecutive odd positive integers. We are talking about pairs. So suppose we are saying that the two consecutive odd positive integers, we are saying they are x and x plus 2. If one is odd, 3 is odd. We are saying x is odd, x plus 2 is odd, 3 is odd, x plus 2 is 5 is odd. So if we are saying x is a odd number, the next positive odd number will be x plus 2. We are saying both of which are smaller than 10. Both these values should be smaller than 10. Both these values should be smaller than 10, and such that their sum is more than 11. We are talking about another condition, that their sum is more than 11. We want to find the odd numbers. X should be odd. We are considering over here that x should be odd. Let x be an odd number. We are saying, or we have started, we are saying let x be an odd number. Consecutive odd will be x plus 2. Another way to do this is that in place of x you have to consider 2n plus 1, where n is a natural number, but we are not considering it this way. This will make the calculations more complex. Just consider it like this, that x be a odd number, next number will be x plus 2, both numbers should be less than 10, sum should be greater than 11. We want to find these numbers. If we look at these two conditions, we are saying x is less than 10 and x is less than 8. Which of these condition is more powerful condition? This value we are saying, because if this will hold, this will automatically hold. Or another way to look at this is, we are having and over here, this is 8, this is 10. We are talking about x is less than 8, we are talking about x is less than 10. What is the common portion we are left with is x is less than 8. Look at this condition now. It is 2x plus 2 is greater than 11. It means x is greater than 9 by 2. We are having x is greater than 9 by 2. 9 by 2 when we are talking about, it means we are talking about 4.5. Now plot these over here. We are having, this is 4.5 over here, this is 4, this is 5, and then we have, this is 8. From this condition we have x is less than 8. We are talking about only the natural numbers. This line you can plot it as the broken line because we are interested in only the natural numbers. So we are talking about the integers 5, 6, 7 and 8. We are saying x should be greater than 4.5. X should be greater than 4.5. So what are the possible values over here? The possible values of x that we can have, it is 5, 6 and 7. We have, what we have considered, let x be an odd number. It means x cannot have value 6. So the possible values of x, they are 5 and 7. Corresponding to 5, the next number is 7, and corresponding to 7, the next number it is 9. So possible pairs that we can have, they are 5, 7 or 7, 9. These are the two possible pairs that satisfy the condition of this problem. Similarly, we have this next question. We are being asked, find the pair of consecutive even integers, even positive integers we are talking over here. We are saying, find all pair of consecutive even positive integers, both of which are larger than 5. Now we are talking about positive integers. Again, x and x plus 2 are there, both of which are larger than 5. We are saying this is even, such that their sum is less than 23. Solve these values. Try to find the values of x, the numerical value, the integer values we are saying, or natural numbers x which satisfy these inequalities. Out of that, consider only the even numbers. The answer you will obtain, the values on solving this, you can try it at your own. The values of x you will obtain, they are 6, 8 and 10. So we will be saying that possible pairs, they are 6, 8, 8, 10 and 10, 12. These are the three possible pairs. So you can try to solve this question at your own and try to obtain this answer. Next is, if a man wants to cut 3 lengths from a single piece of cloth. If man wants to cut 3 lengths from a single piece of cloth of length 91 centimeter. The total length of the cloth, it is 91 centimeter. The second length is to be 3 centimeter longer than the shortest. We have some shortest length. So let us consider that the shortest piece we have, it is x centimeter, is 3 centimeter longest. The second length we have, it is x plus 3 centimeter, and the third length is to be twice as long as the shortest. The third one we are saying, it is twice as long as to the shortest. These three conditions they are given. What are the possible lengths? The total length is also given to us. The man wants to cut 3 lengths from a single piece of cloth of length 91 centimeter. Okay. What are the possible lengths of the shortest piece of the cloth if the third piece is to be at least 5 centimeter longer than the second one? We are saying the total cloth we have, it is 91 centimeter. So we are saying x plus 3 plus 2x, the maximum cloth we have, the maximum length we can have, it should be less than equal to 91. One equation we are getting in this form. So we get, it is 4x plus 3 is less than equal to 91. This implies us 4x plus 3 is less than equal to 91. This implies us 4x is less than equal to 88, and this implies us x is less than equal to 22. From the next condition we have 2x, the second length we have, it is the shortest piece of cloth if the third piece is at least 5 centimeter longer than the second one. So 5 centimeter, we are saying 2x should be greater than equal to x plus 5, 8. This is x plus 3 is there, 5 centimeter longer, it becomes x plus 8. So on solving this you will get that x is greater than equal to 8. So we are saying the possible values of x that we can have, it should be greater than equal to 8 and x should be less than equal to 22. It means that the shortest length that we will have, x, that belongs to both the intervals, they are closed, that belongs to 8, 22. That belongs to 8, 22. That is, the length can be between 8 and 22. Both 8 and 22, they are inclusive. So these are the possible lengths that we can have. Next is the longest side of a triangle is 3 times the shortest side. So we are talking about the sides of a triangle. So let us consider the shortest side, it is x centimeters. Then the longest side we have 3x centimeter. It is given that it is 3 times. And the third side is 2 centimeters shorter than the longest side. So this gives us the third side we have. The third side, it is given to be 2 centimeters shorter than the longest side. Longest side minus 2 centimeters. This is the length of the third side that is given. If the perimeter of the triangle is at least 61, perimeter of the triangle means sum of all these sides, x plus 3x plus 3x minus 2, and this value should be greater than equal to 61. It is at least 61. Then we have to find the minimum length of the shortest side. We have to calculate the value of x. So the answer we will have over here, it is, when you will solve this value, you will get it is 7x minus 2 is greater than equal to 61. So what we get is 7x is greater than equal to 63. So x is greater than equal to, so we have to find the minimum length of the shortest side. So minimum length of the shortest side, it can be 9 centimeters. Next is in drilling the world's deepest hole, it was found that the temperature Tx, the temperature is given to us, in degrees Celsius at a depth of x kilometer below the earth's surface is given by Tx is equal to 30 plus 25 x minus 3, and these are the possible values of x, that is 3 is less than equal to x is less than equal to 15. At what depth will the temperature be between 155 degrees Celsius and 205 degrees Celsius? We want that the temperature, we want that this temperature that we have over here, it should be between 155 degrees Celsius and 205 degrees Celsius. So what we have to do over here? We are saying temperature that we have 25x minus 3, this is the temperature that we have, it should be between 155 degrees Celsius and 205 degrees Celsius. It is between over here, so we use the strict inequalities. So if we solve these two inequalities, these are the simultaneous inequalities, what we will obtain, if we will solve this value, if first of all we are going to solve this value, it is 25x this will become minus 75, and this value will become, it is minus 45. This is the term we are getting. So 155 is less than 25x minus 45, and 25x minus 45 is less than equal to 205. These are the two inequalities we have obtained, and on solving these two inequalities, we will get, when we solve these two inequalities, we will get 200. It is less than equal to 25x is less than equal to 250. This is the value we will obtain. And on solving this, if we divide it with 25, the possible values of x we have, 8 is less than equal to x is less than equal to 9. And the range, the possible values of x that are given over here, that are from 3 to 50, and these values, they lie between the given values of x, 3 and 15. So we are saying that the required depth at which the temperature will be between this and this, it is when the value of x is between 8 and 9. This is not 9 over here, this is 10 over here. This is 10. So the possible values we are saying that will happen over here when the values of x, they are between 8 kilometer and 10 kilo. So these are the possible values of x that we will have. Next question we have is, a manufacturer has 460 liters. We are talking about, he has 460 liters of 9% acid solution. So how much acid is there? We are talking about amount of acid in this case, that will be 9 by 100 into 460 liters. This is the amount of acid we have in this sample. How many liters of 3% acid solution? We have another solution over here. This is 3% acid solution, and we are going to add this solution to it, so that the acid content in the resulting mixture is more than 5% but less than 7% when we add. Suppose the amount we have added over here, it is x liters. We have added x liters. When we have added x liters over here, the new solution we obtain, how much new solution we will have? It is 460 plus x liters of solution. Now we have this much of solution. And what is the acid content over here? The acid content, if we have, this is x liters of solution, then the acid content we have, it is 3 by 100 into 460 liters. This is the acid content over here. 3 by 100 into, not 460, it is x liters. When we have mixed both these, the total amount we have, it is this. And what is the acid content that we have? It is 9 by 100 into 460 plus 3 by 100 into x liter. This is the amount of acid that we have at this point. So if you simplify this value, 460 into 9 by 100, these two terms get cancelled. The answer you will obtain, it is 207 divided by 5 plus 3x by 100. So this much liters of acid is there in this solution. Now it is given that how much percent should be there? This acid should be 5% to 7%. This acid content, it should be, this acid content we are saying, this should be between 5% to 7%. This is given over here. The resulting mixture is more than 5% but less than 7%. It means strict inequalities we are talking over here. So if we rewrite these inequalities, we are saying 5%. 5% of what? The total solution. So if we rewrite these inequalities, this inequality, we will get it is 5 by 100 into 460 plus x is less than equal to 207 by 5 plus 3x by 100 is less than, it is not equal to over here, it is less than 7 into 460 plus x by 100. So our inequality becomes in this form, it comes out to be in this form. Now if we multiply whole of this equation with 100, we multiply this equation with 100, this 100 gets cancelled, this 100 gets cancelled, with this, when this 5 is cancelled, we will get 20 into this, and this 100 gets cancelled. And we will have two inequalities over here. One is 2300 plus 5x is less than, next value we will have it is 4140 plus 3x is less than 3220 plus 7x. So these are two simultaneous inequalities that we will have. And when you will solve these two inequalities, you will get, when you will solve these two inequalities, this is one inequality, this is second inequality. Try to solve these two inequalities. The answer you will get is that x should be greater than 230 and x should be less than 920. So we are saying that if we want to add 3% solution, how much solution we have to add? We have to add the solution between 230 liters to 920 liters to make it 5% to 7% solution. So this is the amount of solution we have to add. Next is, a solution is to be kept. Next is, a solution is to be kept between 40 degree and 45 degree. What is the range of temperature in degree Fahrenheit? If the conversion formula is this. This is the formula for conversion. We want to keep it between these two. It means we have to calculate the value of C over here. You can calculate the value of C. So it is F minus 32 is equal to 9 by 5 times C. So the value of C you will obtain, it is 5 by 9 F minus 32. And it is given that C should lie between, is to be kept between, means strict inequality 40 and 45. It means we have to solve this inequation. We have to solve this inequation, and when you will solve this inequation, you will obtain the possible values of F, and those values of F, the answer you will obtain, that is 104. The value of F we are saying it will lie between 104 and 130. So these are the possible values of F. So you can try to solve these inequalities to obtain this answer. You have to convert it to in terms of C, and then the range for C, the possible values of C are given. We have substituted these values. This will lead to two inequalities. Solve those values and obtain the answer in this form. So you can try this at your home. You can try this question at your home. Next question we have is, the IQ of a person is given by the formula IQ is equal to M by C into 100, where M is the mental age and C is the chronological age. If 80 is less than equal to IQ is less than equal to 140 for a group of 12-year-old children, find the range of their mental age. So the value of IQ is given, the range is given over here, and it is given that a group of 12-year-old children. So 12-year-old children means the value of C is given to be 12. So what we obtain is that IQ we have, that is equal to M by 12 into 100. We want to solve for those values of M for which the value of IQ lies between 80 and 140. We are saying 80 is less than equal to M by 12 into 100 is less than equal to 140. Again, you will have two inequalities, and when you will solve these values, try to solve these values, you will obtain the values of M to be 48 by 5 is less than equal to M, and this value is less than equal to 84 by 5. So the final answer, when you will solve this, try to solve this at your own, you will get that this is for 9.6 is less than equal to M is less than equal to 16.8 years. So these are the possible values over here. So we have 4 or 5 questions that you should try at your own from this lecture, and this was all about the linear the inequality, the simultaneous inequalities that we